we're going to show that the conjugate of a quotient is equal to the quotient of the conjugates. And we'll do this by computing the left-hand side and the right-hand side separately and showing that they simplify to the same thing. So on the left-hand side, we have to compute this quotient and then take the conjugate. So to compute the quotient, we multiply the numerator and the denominator by the conjugate of the denominator. So we have a plus bi over c plus di, and we multiply by the conjugate of c plus di over itself, and that's c minus di. And then we need to calculate the conjugate of this after we do simplify this here. So in the numerator, a plus bi times c minus di is going to be ac, and then plus bd. So ac plus bd. And then the imaginary part's going to be bc minus ad. So plus bc minus ad times I. So there's our numerator. And the denominator, when you multiply conjugates together, you get the sum of the squares of the real and the imaginary parts. So that's going to be c squared plus d squared. And then we need the conjugate of this. So this complex number has real part ac plus bd divided by c squared plus d squared. And then we want the conjugate, so we'll do minus bc minus ad over c squared plus d squared times I. So this is the left-hand side. And now I think we could say that this is the same as ac plus bd over c squared plus d squared, and then plus the double minus here, so bring the minus in and you'll get ad minus bc. ad minus bc over c squared plus d squared I. Okay, so this is our left-hand side. And now we will compute the right-hand side. That's the conjugate, and we'll just do it right here. Continue this. The conjugate of the numerator is a minus bi, and the conjugate of the denominator is c minus di. And then to multiply, to divide those, we have to multiply by the conjugate of the denominator, which is c plus di. So c plus di over itself. Now in the numerator, we get a real part of ac plus bd, and then an imaginary part of ad, and then minus bc. And this is over, again, c squared plus d squared. And then when we divide the real part and the imaginary part of the numerator by this real number c squared plus d squared, we get this expression here. Let's look at it. The real part is going to be ac plus bd divided by c squared plus d squared. And the imaginary part is going to be ad minus bc divided by c squared plus d squared. And that should match this one, ac plus bd, c squared plus d squared, ad minus bc, c squared plus d squared. There we go. So the left-hand side equals the right-hand side, and so we have demonstrated that the conjugate of a quotient is the quotient of the conjugates.